History remembers the Soviet T-34 as the weapon that broke the back of the Wehrmacht. It is the icon of the Eastern Front, celebrated for its revolutionary sloped armor, its mobility, and its ruthless simplicity. Military historians often cite it as the finest tank design of the Second World War, a machine that traded comfort for combat effectiveness in a way that strategic logic dictates is necessary for total war. But if you were to look past the newsreels and listen to the voices of the Soviet tankers themselves, you would hear a different name for this legendary machine. They did not call it a savior. They called it the Bratskaya Mogilathe, Brother's Grave, or more grimly, the Coffin for Four Brothers. This nickname wasn't born from a lack of patriotism, but from a cold, statistical reality. For every T-34 that rolled off the assembly lines at Chelyabinsk or Nizhny Tagil, the life expectancy of its crew was measured not in months, but in engagements. The paradox is chilling. How could the most strategically successful tank of the war also be one of the deadliest traps for the men inside it? Now, let's open the archives and zero in on the story. To understand this tragedy, we must first strip away the mythology of the perfect tank. While the T-34's sloped armor could deflect the high-velocity rounds of German anti-tank guns, the survival of the tank did not guarantee the survival of the crew. Statistical analysis of armored engagements between 1941 and 1943 reveals a disturbing anomaly. When a German Panzer or an American Sherman was disabled, the crew survival rate was relatively high. The men could often bail out and fight another day. In contrast, a penetrating hit or even a non-penetrating hit that caused mechanical seizing on a T-34 frequently resulted in the total loss of the crew. The sheer volume of Soviet tank losses, numbering in the tens of thousands, was not just a result of German ballistics. It was the result of a specific, calculated engineering trade-off. We are looking at a design philosophy that prioritized the mass production of the hull over the ergonomic survival of the human operator. The machine was built to be replaced. The four brothers inside were not. To truly comprehend why these men called their vehicle a grave, we must descend into the claustrophobic reality of the hull itself. Imagine the summer of 1943 on the burning steppe of the Kursk salient. Inside a T-34-76, the environment is not merely uncomfortable, it is toxic. The interior is unpainted steel, rough and unfinished, smelling of diesel fumes, cordite, and the sweat of four men crammed into a space designed for three. The ventilation is primitive, often failing to clear the gases from the main gun, leaving the crew gasping for breath in a haze of carbon monoxide. This is not the smooth, precise operation of a German Panzer III, where ergonomics facilitate combat efficiency. This is a visceral, physical brawl between the crew and their own machine. Consider the driver. He does not steer with hydraulic assist. He wrestles with a transmission so crude that drivers were famously issued sledgehammers to force the gear stick into place during breakdowns. In the heat of battle, he is exhausted before the first shot is fired. But the true nightmare exists in the turret. The T-34-76 suffers from a critical spatial deficiency known as the two-man turret. The commander is forced to double as the gunner. He must spot the enemy through notoriously poor optics, soften just polished steel periscopes rather than high-quality glass, command the driver, load the coaxial machine gun, aim the main cannon, and fire. He is task-saturated, functionally blind, and chemically intoxicated by gun fumes. Below him, the loader faces an even more perilous dynamic. Unlike Western or German tanks, the T-34 lacks a turret basket, a rotating floor that moves with the turret. When the commander traverses the gun to the right, the loader must physically scramble over boxes of ammunition and spent shell casings on the stationary floor to keep up with the breach. If he trips, or if his leg gets caught in the traversing gear, he is maimed. It is a chaotic dance performed in the dark, amidst the deafening roar of a V2 diesel engine located just behind a thin bulkhead. The noise is so overwhelming that internal communication is impossible without an intercom, which is frequently broken or absent entirely. Instead, the commander kicks the driver's shoulders, left shoulder to turn left, right shoulder to turn right, a foot in the back to stop. They are fighting deaf, dumb, and blind. Then comes the impact. When an 88mm shell strikes the T-34, even if the sloped armor does its job and deflects the round, the kinetic energy transfer is violent, spalling razor-sharp flakes of steel shears off the interior armor face, shotgunning the crew. But let us assume the tank is penetrated. The fuel tanks are located inside the fighting compartment, flanking the engine. A hit often ignites the diesel immediately. The hull becomes an incinerator within seconds. This is the precise moment where the Coffin designation moves from metaphor to reality. In a Sherman or a Panzer, the crew has spring-loaded hatches, side escape doors, or floor hatches. In the T-34, the panic of the fire meets the stubbornness of the design. The crew, disoriented and burning, instinctively reaches for the light above them. They push, and often, nothing happens. The exit, their only route to survival, has become a sealed lid. The tragic irony is that the very armor designed to keep the enemy out has now locked the crew in. To understand why they cannot escape, we must stop looking at the crew and look at the hatch itself, a piece of metal that represents a fatal misunderstanding of human engineering. The forensic analysis of the T-34's lethality to its own crew centers on a specific, catastrophic bottleneck: the hatch design and the metallurgy of the hull itself. When we deconstruct the engineering schematics of the T-34-76, specifically the model 1941 and 1942 variants that bore the brunt of the fighting at Stalingrad and Kursk, we find a mechanism that actively works against human survival. The primary culprit was the main turret hatch. On these models, the Soviets utilized a massive, single-piece steel slab that covered the entire rear of the turret roof. This design decision was born of industrial necessity. Casting a single large opening was significantly faster and required fewer machining hours than creating the complex multi-hatch cupolas found on German Panzer III and IV tanks. In a factory in the Urals, this saved precious minutes per unit. On the battlefield, it cost seconds that the crew did not have. Consider the physics of the escape. This single hatch weighed heavily. It was a solid plate of armor. It did not possess the counterbalanced springs found on American Shermans, which allowed a hatch to pop open with a light push. Instead, the T-34 commander, often wounded or disoriented by the concussion of a hit, had to physically bench press this heavy steel plate upwards and throw it forward to lock it open. If the tank was on a slope, or if the hull had twisted from the impact, gravity would fight him. If the hinge mechanism had been fouled by debris or deformed by the kinetic energy of a non-penetrating hit, the hatch became a permanent seal. Furthermore, the shared nature of this single hatch created a fatal traffic jam. The commander and the loader had to exit through the same aperture. In the panic of a fire, this created a bottleneck where seconds of hesitation led to asphyxiation or incineration. Compare this to the German design philosophy, where the commander, gunner, loader, and driver often had individual or adjacent egress points. The German tank was designed as a fighting vehicle for men. The T-34 was designed as a mobile pillbox, where the crew was a component, not a priority. But the Coffin designation was not just about the turret. It extended to the driver's station. The driver's hatch on the front glacis plate is perhaps the most notorious design flaw in armored warfare history. While it provided excellent entry for the driver in non-combat situations, in battle, it became a trap. The hatch was heavy, armored steel, flush with a sloped front. If the main gun was rotated forward and depressed slightly, a common combat posture, the barrel physically blocked the hatch from opening. The driver was effectively sealed in by his own weapon. Moreover, the location of the hatch on the front glasses compromised the integrity of the frontal armor. It was a structural weak point. German anti-tank gunners learned to aim specifically for the driver's hatch, knowing the welding seams were vulnerable. A hit there would often buckle the plate inward, crushing the driver, or weld the hatch shut through the heat of impact. Even if the driver survived the initial strike, if the hatch was jammed or blocked by the gun, his only alternative escape route was to crawl back into the fighting compartment, scramble over the ammunition racks, and try to exit through the turret. The same turret that was likely already engulfed in flames. We must also analyze the metallurgy itself. The T-34's high hardness armor was excellent at shattering shells, but it was incredibly brittle. Soviet metallurgy during the peak war years suffered from a lack of rare tempering metals due to supply shortages. When a high-velocity German shell struck the T-34, even if it did not penetrate, the shockwave would travel through the brittle steel. This often caused the interior face of the armor to shatter into high-velocity shrapnels, spalling without the shell ever entering the tank. But structurally, this shockwave had a secondary effect. It warped the hull frames. The tolerances on the T-34 were loose to begin with, often leading to gaps that let in rain and snow. But under impact, the crude machining meant that hatches and escape panels would bind instantly. This leads us to the why of the design. Why would Soviet engineers, who were brilliant innovators, accept such fatal flaws? The answer lies in a ruthless calculation of operational lifespan. By 1942, the average operational life of a T-34 on the front line was calculated to be approximately 14 hours. From a systems engineering perspective, adding complex escape mechanisms, precision-machined cupolas, or ergonomic interiors to a vehicle that would likely be destroyed in less than a day was considered a waste of resources. The logic was industrial. It was more effective to produce 3 tanks with fatal flaws than 1 tank with perfect survivability. The Coffin for 4 brothers was not an accident. It was a product of an equation where the variable of crew survival was set to 0 in favor of production volume. Ultimately, the story of the T-34 forces us to confront the most brutal calculus of the Second World War, the difference between a tactical tragedy and a strategic victory. When we step back from the forensic details of the jammed hatches and the spalled armor, we see the grand logic of the Soviet war machine. The engineers in the Kharkiv locomotive factory and the planners in Moscow were not ignorant of these flaws. They simply operated on a scale where individual survival was statistically irrelevant. The goal was not to build the best tank for the tanker. It was to build the best tank for the war. The T-34 was designed to be built faster than the enemy could destroy it. German tanks like the Tiger and Panther were masterpieces of engineering, ergonomic, survivable, and precise, but they were complex and slow to produce. The Soviet philosophy accepted that the T-34 was a consumable munition, much like an artillery shell. The heavy single-piece hatch was chosen because it saved machining time, allowing thousands more tanks to reach the front. The brittle, high-hardness armor was used because tempering agents were unavailable, and a brittle tank on the field was better than a perfect tank in a factory. This industrial ruthlessness won the war. The sheer tide of T-34s overwhelmed the technically superior German panzers through attrition and maneuver. But for the crews inside, this strategic genius was a death sentence. The Coffin for 4 brothers was the human receipt for that industrial success. The men who climbed into these machines knew the odds. They knew that if the engine seized, the transmission failed, or a shell struck the glacis, the design of their own vessel would likely conspire against them. Yet they climbed in anyway. They drove these claustrophobic, deafening, and dangerous steel boxes from the Volga to Berlin. The victory of the Red Army was built on the willingness of these crews to operate a machine that treated them as the most replaceable component of the system. The T-34 remains a paradox of military history. It is rightfully hailed as a mechanical wonder that saved a nation. Yet it achieved this by disregarding the safety of the men who served it. When we look at the T-34 today in museums, sitting silent and cold, we should not just admire the slope of its armor or the caliber of its gun. We should look at the heavy steel hatch on the turret roof. We must remember the terrifying strength required to open it, and the thousands of brothers for whom it remained forever closed.